You will need graph paper and a straight edge for today's lesson. If you have your blue sheet on hyperbolas, you should get it out. Today we're going to be talking about hyperbolas. The homework exercises are on page 445, 21 through 33 odd, and you will need graph paper. A hyperbola is a set of all the points in a plane such that the difference from point P to two fixed points is constant. The fixed points are called foci. A hyperbola has a transverse axis. The word transverse means to cross. The transverse axis is the axis the hyperbola crosses. It is one of two axes which the hyperbola is symmetric to. The transverse axis contains the foci, and the length is 2a. The positive term determines the transverse axis. The conjugate axis is the axis the curve does not cross. It is one of two axes to which the hyperbola is symmetric. It does not contain foci, and its length is 2b. It is the negative term. The center is H and K. It is the midpoint from foci to foci. We also will be having asymptotes, which are lines the curve gets closer and closer to but never intersects. The equation for the foci is a squared plus b squared is equal to c squared. A hyperbola has two branches. This is a branch and that's a branch. This particular hyperbola is horizontal. The equation is x minus h squared over a squared minus y minus k squared over b squared. And you'll see that this particular hyperbola, that the x is the positive term and the y is the negative term. So that's why it is horizontal. The foci are always on the inside of the branches. This particular curve you see where its transverse axis is the y-axis. So we have y minus k squared over b squared minus x minus h squared over a squared is equal to 1. These lines are what we call the asymptotes. It's the curve. It's the line the curve gets closer and closer to but never intersects. So let's go back and look at the equations. You'll notice on the first equation that the minus sign is in front of the y, so it is the conjugate axis. And the positive term, this is positive here, is a transverse axis. So if it is in this form, the curve faces left or right, the branches. If y is positive, it is a vertical and looks like that. So the positive term determines the transverse axis. So my first example says 9x minus 2 squared minus 4 times y plus 3 squared is equal to 36. So the first thing we would do here is divide everything by 36. And we get x minus 2 squared over 4 minus y plus 3 squared over 9 is equal to 1. I no longer care which denominator is larger or smaller. What I care about is which term's positive and which term's negative. So you see where that term is positive. So the transverse axis is the x-axis and the conjugate axis is the y-axis. The center is still h and k, so it is 2 and negative 3. H always goes with x and k always goes with y. A squared is equal to 4. So a is equal to plus or minus 2. B squared is equal to 9. So b is equal to plus or minus 3. The length of the transverse axis would be 2 times 2 or 4. And the length of the conjugate axis would be 2 times 3 or 6. The foci is a squared minus b squared is equal to c squared. So that is 4 plus 9, which is equal to c squared. So c is equal to the square root of 13. Now when we draw this, we're going to draw what I would call the skeleton. That's the bit that holds the branches together, or to draw the branches. So we're going to plot the center at 2 and negative 3. Then we're going to go to the right 2 units and to the left 2 units. Then we're going to go up 3 units and down 3 units. Then we're going to draw the rectangle. So when we draw this rectangle, we have a rectangle that looks like that. Then we're going to draw the asymptotes. The asymptotes go from corner to corner and through the center. Like I said, this is not the hyperbola. It is what I call the skeleton that holds the hyperbola together, because this hyperbola is horizontal. We're going to go to these points, which are the vertices, and draw our curve from there, not from the center, but from the vertices. And the curve gets closer and closer to these asymptotes as it goes further and further out. It never crosses them. So there's our hyperbola. My next example is a little bit more complicated because we need to put it in the correct form. So the first thing we're going to do is put all the x's together. We're going to put all the y's together. And when you put the x's and y's together and you put your parentheses around everything, you move the constant to the other side of the equation. Make sure that you keep this negative sign with the number. So next we're going to factor out 4 and get x squared minus 8x. Then we'll factor out a negative 9 and get y squared plus 2y. Remember, we'll take half of 8, which is 4, and square it, so we're adding 16. But we're adding 4 times 16. We're adding 4 times 16. Then half of 2 is 1. 1 squared is plus 1. But we're not adding 1. We're adding negative 9 times 1. So we're adding negative 9 times 1. So here we have 4 times x minus 4 squared minus 9 times y plus 1 squared is equal to negative 19 plus negative 9 is negative 28 plus 64 is 36. Divide everything once again by 36. So 4 goes into that 9 times and into this 4 times, and that becomes a 1. So now we have x minus 4 squared over 9 minus y plus 1 squared over 4 is equal to 1. So let's find our center. So we have a center at 4, negative 1. We'll plot that point, 4, negative 1, over 4 down to negative 1. We have a transverse axis that's the x-axis. We have a conjugate axis, which is y. We have a squared is equal to 9, so a is plus or minus 3. B squared is equal to 4, so b is plus or minus 2. Have a length here of 6 and a length there of 4. So let's go ahead and graph it before we find the foci. So we have over 3 units, 1, 2, 3 units, over 1, 2, 3 units. Then we're going up 2 units and down 2 units. We then want to draw our rectangle. So we have a rectangle that looks like that. And we want to draw our asymptotes. Remember, your asymptotes go through the center and from corner to corner. Then after that, we want to draw our curve. So we will go to our vertice that's the x and draw our curve. Then the focus once again is a squared plus b squared is equal to c squared. So c is equal to the square root of 13, which is between 3 and 4. So 1, 2, 3, 4. So about here, we'll call that focus 1. And then about there gives us focus 2. Our next example is actually a homework exercise. On hyperbolas, the only real vertices are on the transverse axis. We've plotted the vertices for the conjugate, but we don't really use them. So the first thing we need to do here when it asks us to write an equation is to find the center. So negative 5 plus 5 divided by 2 and 0 plus 0 divided by 2 will give us the center. So we have a center at 0, 0. We know that those vertices are on the transverse axis because the transverse axis is the only axis that really has any vertices. So those points are on the x-axis. So we're going to say x minus 0 squared minus y minus 0 squared is equal to 1. Now we have to determine what a and b are. It said the length of the conjugate axis was 12. So 2b is equal to 12. So b is equal to 6. So we have 6 here. We know that the distance from -5 to +5 is the absolute value of -10, which is 10. So we know the length 2a is equal to 10. So a is equal to 5. So we have 5 here, and now we have our equation. Remember, you will need graph paper for your homework. And the homework exercises on page 445, 21 through 33 odd.